Assalamualaikum warahmatullahi wabarakatuh and a very good day to Dr. Nurul Huda. I am Muhammad Fairuz bin Azmi with metric number S60142. Today I will be presenting about ocean ion fertilization. Okay, let's start. First of all, what is ion fertilization? Ion fertilization is a method where iron is being poured into the open ocean. But why humans do this activity? This is because we want to stimulate the growth of phytoplankton and also to enhance the oceanic carbon sequestration through biological pump. So how do scientists start thinking to do ocean ion fertilization? At first, scientists are curious about the atmospheric gas composition during the ancient time. But how do they will get gases from the 100 years ago? Well, they analyzed the trapped air bubble in the Arctic-Antarctic ice and discovered that the last glacial maximum, or also known as LGM, approximate from 20,000 years ago, that the carbon dioxide level in the atmosphere during that time was around 180 ppm, which is much lower compared to the carbon dioxide level during the pre-industrial times, which comes around 280 ppm. So, who proposed the idea of ocean ion fertilization? The person was John Martin, who worked as an American oceanographer that proposed the idea of OIF. He hypothesized that the ocean ion fertilization could be an effective method for stimulating oceanic carbon sequestration through the biological pump in high nutrient, low chlorophyll regions. So how did Martin come to this finding? So dust input are considered as natural ion fertilization. Back in the last glacial maximum, he suggests that dust input are high and it will enhance the oceanic carbon sequestration through biological pump, which resulting in low CO2 level in atmosphere. When the first hypothesis was published, there has been an enormous interest in ocean ion fertilization because only a small ion is needed to stimulate the phytoplankton response. The main objective of OIF is to provide macronutrients for phytoplankton to help in their growth so that the more biological pump will occur, which resulting in increase the uptake of CO2 into the ocean and decrease the level of carbon dioxide in the atmosphere. These are the example of area where the ocean ion fertilization takes place. First, we have equatorial Pacific and Southern Ocean, where these regions are considered as high nutrient, low chlorophyll. These places were chosen based on the iron hypothesis that was proposed by John Martin. Also, OIF also takes place in low nutrient, low chlorophyll region, such as subtropical North Atlantic. What are the correlation between iron and climate change? So, the relation is that iron plays a crucial role in providing nutrients for phytoplankton. This will help in bloom phenomenon to occur. As we know, phytoplankton do photosynthesis in their life. So, a higher number of phytoplankton resulting in increase in photosynthesis process. This will enhance the oceanic carbon sequestration through biological pump that will increase the uptake of CO2 into the open ocean. Thus, it will reduce the global warming on Earth. So, how many ocean ion fertilization projects have been performed? A total of 13 artificial OIF and 6 natural OIF have been performed. In this pie chart, we can see that 7 OIF have been performed in Southern Ocean, 3 in subarctic North Pacific, 2 in equatorial Pacific, and 1 in subtropical North Atlantic. During the experiment, there are some limitations that occur, such as insufficient experimental period, single ion addition, and light limitation that occur by storm. Are all these experiments achieving its main aim and considered a success to remove carbon from the atmosphere and increase in carbon sequestration? From my understanding, there are not a clear point to know whether the experiment already achieved its main objective. So, here I separate into positive and negative results. The positive result is that they achieve in changes of size phytoplankton from pico to micro phytoplankton, and only effects expedition that considers as a success where significant carbon export to the deeper layers of ocean. The negative results are there are no confirmation on the effectiveness in enhance to export the production, and there are some side effects on environment, which is declining in oxygen content in some of the experiment region. Lastly, we move on to the preparation of OIF in the future. There are 6 points that we need to talk about. First is the location. The dominance of diatoms in phytoplankton communities plays a major role in increasing the biological pump because diatom species can sink rapidly. Next is timing. Scientists should be prepared because nutrient and light availability might differ throughout the year. Third point is the duration. The period for phytoplankton to bloom might differ as it may take time from 10 to 40 days to fully occur. Fourth, success of OIF release relies on proper planning such as adding and maintaining dissolved iron within the ml to produce a phytoplankton bloom. Fifth is the effective tracing of the fertilized patch, including the detection of carbon sequestration. Scientists should use physical tracer or use satellite for the detection. And is the monitoring possible. Lastly is the monitoring of possible side effects on the environment. And that's all from me in ocean ion fertilization. Thank you for listening.